Hello everyone. So the quiz 6 will be on non-homogeneous second order linear equations with constant coefficients. And so I remind you, we have the non-homogeneous part, we can only do certain types, and that is, it has to be a exponential times a polynomial, okay? Okay, so of course, there's all the steps that needs to be done. Step 1 is we have to solve the complementary homogeneous one. So that is y double prime minus 3y prime plus 2y equals 0. So that with constant coefficients, we know that is the characteristic equation. Don't do this characteristic equation for other second order, but for this one you can do that. T squared minus 3t plus 2 equals 0. So we have to factor this as two numbers that add up to negative 3 and multiply to 2. That seems to be negative 1 and negative 2, right? So we see two roots, t equals 1 and t equals 2. Okay. So that's step 1. Well, no, now we can write a homogeneous solution. There's nothing to calculate, it's just a formula. It is, these become the coefficients of, in front of x in the power of the exponential. So we have a e x, that's the one that I use, and then b e 2x, that's the root 2 that I use. Okay, that's where we are. Now, step 2, we know that because of this special form here, we know that we're going to look for a solution of the form y equals u ex. What is this ex? This is this exponential in front of this. Okay. Now it happens to be one of the solutions. We know that this is a special case, right? So let me point out here, alpha is 1, which is a root. So something is going to happen. We will see it happen anyway, but it's good to anticipate it already. Okay, so we have to calculate y prime, u prime ex plus u, and the derivative of ex is just ex, so y double prime is u double prime ex plus u prime ex plus, now the derivative of the second one, but that is u ex plus u prime ex plus u ex. So if I plug everything into the original equation, I get u double prime ex. Right. In this case, it's not so much writing, but in general, of course, we want to be economic as possible, and we know that we will have an ex at both sides. That's the whole point, to get the whole point of this substitution, which we should perhaps box, because we have to go back to it. We're going to find u, and then we have to go back to find y. So we know that this type of substitution is going to exactly make the exponential disappear, so that the forcing function is only a polynomial. Okay. So that's why I put this out, and then now y prime, so there is a u double prime. Now I can combine these two terms, so there's a 2u prime plus u, and then it was minus 3 times y prime, so minus 3, these guys, and minus 3u prime, minus 3u, make sure that you expand it, otherwise take your time, plus 2 times u. Okay, and that is ex, the original 3 minus 4x. And as said, what has to happen for sure is this. Now, something else happens. If we look at the u terms, we see u plus 2 minus 3u. Why is this happening? This is happening because alpha is a root. Okay, it's a root of multiplicity 1. It's one of the two roots. So only the u cancels. There's a special case. I'll do, I think, the next example is where we have a double root where there's only one root of the characteristic equation, and in that case, more cancels, but okay. We know that this is cancelled, so we get u double prime plus 2u prime is equal to 3 minus 4x. Now, it is important that we know this. So there's no u term. This means that we have to, what we're going to propose now is u, and because there's no u term, we're going to have to x times a polynomial of the same degree here, and that's degree 1, so a plus bx. Okay, so I repeat, this x comes from the fact that there is no u term. Okay, that's what you do if there is no u term. That is what you do if alpha is a root of the equation. What is this part? This is polynomial with general coefficients or indeterminate coefficients of the same degree as the polynomial that you have here. Okay. Now, this is what we're going to work out, but it's, of course, it's better. What happened here? I don't know what happened here. To expand this, right? Ax plus bx squared, because we're going to have to take the derivatives. So u prime is a plus 2bx, and u double prime is therefore 2b. Okay, we plug this all in here, right? So we get 2b plus 2a plus 2bx is equal to 3 minus 4x. So that means 2b plus 2a plus 4bx is 3 minus 4x. We know that this now compare coefficients. So compare coefficients. Okay, so what you need, you don't bring anything from one side to the other side. You keep the known one on the right and the undetermined one on the left. And then you compare coefficients. So we have these two coefficients are equal. So 3 equals 2a plus 2b. And then the other one is this is equal to that. So minus 4 is equal to 4b. This tells us already that b is negative 1. Of course, once you have that, you just plug it in there. That is 2a minus 2. So that means that 5 is equal to 2a, and it means that a is 5 halves. Okay, so we find as solution, where are we? U is, here is u, right? A, so 5 half x plus, so minus, here is b, right? Minus 1x squared. Okay. That is u. Is that the solution? No, because this is just part of something, right? So, give me a sec here. Just wanted to double check that I didn't, with my notes here, that I didn't make anything. Okay, so what bothered me was that there was a fraction, and I don't remember having there a fraction. Did I make a mistake here? Ax plus bx squared. So u prime is a. No. U prime, and then it is, we plug it into the equation. Oh, I see here. I was too quick here. There's another term here. So this is minus u prime. Okay. So this is minus u prime. Okay. So instead of a plus 2, this is a minus here. So okay, we have to just adjust these things here. So that's a minus. So let me erase everything else here because it's gonna be. So we get 2b minus a minus 2b x is 3 minus 4x. And now we compare coefficients. So 2b minus a is 3, and minus 2b is minus 4. Okay, so 3 is 2b minus a, and minus 4 is minus 2b. So this takes that b is 2, and if I plug this in, I get 3 is 4 minus a. This means that a is 1. Okay, that's more like it. So I find a particular solution is, where is it? Here, here's my guy, is x plus 2x squared. Okay, now, no, sorry, this is u. Sorry, I'm going again a bit too fast. This is u, but what is y then? Well, we have to go to this box thing here, so we have to still multiply this with ex. Okay, so then the last step, the general solution. Well, this is a particular solution, and we know that the general solution is the particular solution plus the general homogeneous solution. I'll just write that for the moment down the formula. So that is just basically you take this guy, 2x squared ex, and then you add the general, is it this one? Yeah, this one, right? Oh, yeah, homogeneous one, okay. So that's the general solution, and then there could be an initial value problem that we can solve. I'll do one for the next one. Okay. So let's do another problem now. Sorry, not number. Give me a sec here. I have to pull it up. Where did I put it? Let's do this one here. 9. That's a 9, not a G. 9y double prime plus 6y prime plus y is e to the minus x over 3 to minus 4x plus 4x squared. Okay, and let's do, I'm going to do an initial value problem, but I didn't actually really check this part, so this might come out a little bit awkward, but let me, give me a sec here. If x is 0, if x is 0, then I'm going to just write something here. It's probably going to be ugly. I might change this just because I didn't prepare this part. I did for the other one and didn't use it, but okay, let's go with it. So step 1. It is again of the form that we know we can solve with this method, right? It's an exponential times a polynomial, and this is a constant coefficients. Okay. So we look at the complementary homogeneous. So that is 9. I said my 9. 9y double prime plus 6y prime plus y equals 0. So the characteristic equation is 9t squared plus 6t plus 1 equals 0. Now we have to factor this, and this is where, again, a little bit annoying is that the 9 is there in front, right? But, a is not 1. But if you know a bit your formulas, you see that this is actually a double product formula. And so this factors as that. Now, if you don't see that, there's always the quadratic formula that you can use, right? But you can also use the AC method, right? So in the AC method, you will need two numbers that, you take the product of this and this, that's 9. And then you look for two numbers that multiply to 9 and add up to 6. That's 3 and 3. And then you split this 6 as 3 and 3. And then you factor, you group, and that's what you will get. I'm not going into the details. So what does this tells us? This two things happens. Well, first of all, this 2 here tells me there's only going to be one root, right? This is a root with what we would say multiplicity 2. And the root is minus 1/3. Okay. So we can write down the homogeneous solution, and this is already a special case, right? So this is multiplicity 2, or which means the same thing as a single root. We know that then this become we're going to take e to the minus 1/3 x, right? That will be one of them, but we can only take it once. We cannot take it twice because it doesn't give us anything to know. We know that we have to do that times x, okay, minus x over 3. Okay, so that's the so step 2. That's homogeneous. That's kind of independent, the calculation at least for the particular. So now we're looking for a particular solution. And we know this will be for y is u to the, and what we put here is the exponential that is present here. So minus x over 3. So again, here we see that alpha is minus 1 over 3, and that's even more special because it is now a double root, or double, yeah, I know this is a bit single root or double root. People say we can have used both things for meaning the same thing. It's a little bit awkward to say, but there's only one root, and that is even alpha. So even something more special is going to happen, but we will see that. So okay, so we know that we have the kind y prime, and that is u prime e minus x over 3 minus 1/3 u e minus x over 3. That's the derivative of the exponential, right? And then the second derivative is u double prime e minus x over 3 minus 1/3 u prime e minus x over 3 minus, now we take the derivative of the second term, the first factor, that's the derivative of the first factor, and then the second factor, that's another 1 minus 1/3, so altogether 1/9 u e minus x over 3. Okie dokie. So we know that we can factor out this minus 1x cube. And what we have then? Y prime is there's a u double prime, there's a minus 1/3 and minus 1/3, so minus 2/3. I'm gonna combine them already. I have a 1/9 u, 1/9 u. That is the, oh, but we had to multiply this with 9. So we have 9 times this. So, okay, I need a little bit, well, let me see. Well, let me move this around a little bit. So, 9 times this guy, plus 6 times, be careful, right? There is sometimes this coefficient in front of it, 6 times y prime. So 6 times u prime minus 1/3 u. Again, the e part, the exponential is factored out. And then the last one is just plus y, so plus u. Okay, and that is equal to e to the minus x cubed. And then we had that polynomial 2 minus 4x plus 4x squared. 2 minus 4x plus 4x squared. Okay, and we know that exactly happens, what needs to happen is this. But we also know that because of this here, so double exclamation mark, two things are going to happen, right? Let's see. Let's expand this. We get 9u double prime. Then we get minus 9, the 9 with the 3 cancels, so there's only 3, minus 6u prime plus u, I'm expanding, plus 6u prime minus 2u plus u. Now let's look at what happens to the u primes. They cancel. And let's look what happens at the u. They cancel. Okay, so this double cancellation is because of this doubling here, because of this factor, because we factor this characteristic equation that is, it's a square. Okay, so what does that mean? Well, on the right, what we still have is this, right? It means, well, our life is much easier because we just have to now antiderive this twice. There's no need to do the method of indeterminate coefficients here because it's easier to just antiderive. You can do it, and what would you have to do then? Well, just if you want to do it, what is it? I'm not going to write it down, I'm going to say it. What would it be? What would you propose? Well, you would have been, first of all, because of this doubling here, has to be, instead of, here is the one that I proposed in the previous one, right? Was it here? Instead of the double, this should be an x squared now, and then instead of a linear, I'll have to write a quadratic here because the right-hand side is a quadratic, right? That's a quadratic. But that is a lot of work for something that is not necessary because I can just antiderive here. That is 1/9, let's keep the 9 out, 2x minus 4x squared divided by 2, so it's 2x squared, plus 4x cubed divided by 3, and plus a constant. We are gonna, no, we don't need, yes, it's not necessary, so we're not going to do that. We only need a particular solution, right, because we're going to put it together later on the end. And then another, and one more antiderivative is 1/9 x squared minus 2x cubed divided by 3 plus x cubed divided by 3. Okay, so this is how it looks like. You could now factor out a couple of things. Let's factor out x squared over 3. So that would become the 27, the 3 here. Then there would be an extra 3 there, right? And then the other ones would be 2 minus x. Oh, this is x to the 4th, right? Because I ended the I forgot to add 1 to the exponent. Plus x squared. Why do I know this? Well, it cannot all of a sudden change, right? I know this is 3 different powers each time, and all of a sudden the powers were the same. That's not possible, right? Okay, so the 1/3 came out, and the 1/3 came out, that gave me a 3 here. The x squared came out, that's what I get here. Okay, everything is good. Is that the solution? No, because y was, where is the box? We didn't box it. Oh, I should box it. Always box your things. All right, here we are. So we have to multiply this with e to the minus x cubed. So x squared e to the minus x over 3, sorry, I say it's the cube, 27. And then we have x squared minus 2x plus 3. Okay, so what is the general solution? That is this guy, x squared e minus x over 3. No, sorry, let me write this a little bit neater. Minus x over 3 divided by 27, x squared minus 2x plus 3 plus a times e minus x over 3 plus bx e minus x over 3. And so in fact you can actually factor out the e minus x over 3 in everything. So now I had the initial conditions. If x is 0, I said y is 1, but I might change this number, okay, just to make it nice. Let's see, this is y, right? If I plug in 0, well, almost everything disappears except for the first, this guy here. So I get 1 is a. Well, okay, I'm definitely not going to change that. I like that. But now I have to take the derivative, and that gets a little bit more messy. Now, if you know a little bit what derivatives do and so on, you know that if you take the derivative of this thing, okay, there is an e there, granted, but the rest is at least quadratic. So, and by taking derivative, this can only go down once. So if you take the derivative of this whole thing, it's going to still be a multiple of x, and if I plug in 0, it's going to disappear. But okay, you might not see this, so let's do this. Which is kind of a lot of work, so perhaps it's better therefore to not write it as a full product, but I'm going to write this now here as e to the minus 27, and expand here x to the 4th minus 2x cubed plus 3x squared. So this I rewrote this term like that one. So if I take derivative, derivative of the exponential would give me an extra minus 1/3, so that would together with the 27, 81, right? So I multiply it with this 27, e minus x cubed, and then just this x to the 4th minus 2x cubed plus 3x squared, plus e to the minus x3 over 27, and now I take derivative of this inside, from the second factor, 4x cubed minus 6x squared plus 6x. But this, see now what I said, all this is still, if I plug in 0, it will all disappear, but okay. And then derivative of this guy, that's going to be a minus 1/3 coming out, a e minus x cubed. And then here, of course, again, we're going to have with two parts, right? The derivative x is 1, and copy the second. Plus, now we take the derivative of the second and copy the first. That's this. But again, if I plug in 0, so as I said, so x is 0, right? Then everything here, all these guys are gone, and I find that 1 is equal to minus 1/3 a plus b. Okay. So let's make y prime. Okay, that's okay that there's a fraction here, right? Because we know that a is 1, so get 1 is equal to minus 1/3 plus b. So we see that b is 1 plus 1/3, that is 4/3. So our solution is okay. So since I have now factored out e, I'm going to factor out e minus x3. As I said, there are so many ways that you can write this, right? But okay, I'm going to write it this way: 127 x to the 4th minus 2x cubed plus 3x squared, right? So that is this one here, but I factor out e minus. Then I have the a, which was what was a? 1, yeah, plus 1. And then the b was plus 4/3 x. Right, that was b, right? And so here we have this a here and the bx, right? After we factor out e to the e minus 3. And so what you actually see is indeed here, this whole thing is actually a polynomial, a true polynomial of degree 4, with all coefficients are non-zero here, but could have been 0, but so this is what you normally would get in this kind of thing. Okay. So this was a very special case, perhaps too special to do on a quiz, but still, I mean, it might happen. So we'll see what the gods decide that it will be on your quiz. All right.